Michael, the technology in terms of determining how strong these systems are has dramatically changed over the last 40 years.
Yeah, Paul, back in the early 70s, we relied primarily on hurricane hunters that flew out into these storms that actually observed the pressures, the winds, the temperature, and they used these devices called dropsondes. They dropped these down through the atmosphere, and that's what actually measured the intensity of the storms. You can look back at 1970, 90% of our observations came from aircraft back in 1970, but those aircraft were decommissioned in the Western Pacific in 1987, so we rely primarily now on satellites. Remember, in the early 70s, satellites were in their infancy. Now, earlier today, we demonstrated how these devices called dropsondes work. Take a look.
So this is a dropsonde. This is the device that is used by hurricane hunter aircraft and dropped into hurricanes and typhoons to measure temperature and pressure and humidity. And this is actually an older version of dropsonde that's bigger than the ones we use now.
Yeah, it is. And, you know, the planes will be flying in at about roughly 10,000 feet. That's the most often altitude that they go into these systems. And they drop these instruments right out of the middle of the plane, and these things would fall from that altitude and collect data on their way down. So it's very valuable information, gives us a really good idea of what the storm structure is like on the inside.
And there are three main instruments in this tube, and they're put into the bottom of the tube. It's a pressure sensor, humidity, temperature sensor. So it's measuring all of these things as it's falling down to the surface of the ocean, and also collecting wind observations or wind estimates all the way down.
Well, soon after these instruments are dropped from the aircraft, an initial parachute comes out. It's like a stabilizer that helps sort of stabilize the dropsonde from rotating and getting torqued in all these different directions. And once it's stabilized, then the secondary chute comes out, and that's what carries it all the way down to the ocean surface. And it's along that descent that we're able to take the measurements, as Michael and Carl were saying, of the internal structure of the storm.